Hello there and welcome. In this tutorial we're going to be looking at the Sloshing Tank project. So we're going to begin by loading up our macros, and we're going to be using the DualSPHysics.py macro. And we are going to begin our new case. On the right hand side there we click new case. And the first thing we're going to do is change from 3D to 2D with a Y position of 0, and we're going to position that in view by clicking that in the top left there. So first we need to define our case limits. So we're going to define the position, and we're going to have an x coordinate of -500, a y coordinate of 0, and a z coordinate of -100. And again, just position that in view by clicking the top left there. Then we're going to have a height to our domain of 700 millimeters. So we're going to begin building our geometry. So we're going to start with a cube, so we click the yellow cube in the top there, and we're going to label this as water. We're going to position this at -450 in x and -50 in y, with a length of 900 millimeters, a width of 100 millimeters, and a height of 100 millimeters. We're going to create another cube, and this is going to make up our tank, so we're going to call this tank. We're going to position this again at -450 in x, again -50 in y, and 0 in z. And we're going to give this a length of 900 millimeters, a width of 100 millimeters, and a height of 500 millimeters. So now ready to add these parts to our simulation, so click Add to DSPH Simulation at the bottom there. We're going to change our type of object for the water to fluid, and everything else is going to stay the same. In tank, Add to Simulation again. Type of object is bound again, but fill mode is going to be face. So we're going to click face just there, and we're going to define our motion. So we're going to set motion to true, and we're going to create a custom motion that we're going to call Sloshing Tank. Now if we just make this a bit bigger so everything can be seen, we're going to add a sinusoidal rotational motion. So we're going to have our tank rotate between -1y. We'll just make this a little bit bigger so this is clear, and 0.25 in z, and then 1 in y, and again 0.25 in z, with a frequency of 0.5 Hz and an amplitude of 0.14 radians, and with a duration of 5 seconds. Okay. Now our constants are going to remain as they are, so all are default here. Our execution parameters, we're going to change step algorithm to symplectic. We're going to change viscosity value to 0.05. We're going to change timer simulation to 2.5 seconds. And that's all okay. And we're going to change our interparticle distance to 0.002. And we're ready to save and run our gen case. We'll just call this Sloshing Tank. And we'll just check this to make sure everything's as we expect it to be. So we just click apply, just bring that back. There you go. Everything is as we would hope it is. So we can go back into FreeCAD, and we're almost ready to run the simulation. However, we need to add some additional parameters. So what we're going to do here is we're going to make it so that our domain can move. Because the tank is rotating and moving, we need to be able to have our domain shift. So what we're going to put in here is domain fixed colon 0.55 colon -0.1 colon minus 0.1 colon 0.55 colon 0.1 colon 0.6. Okay, and we'll just save the case. Now we're ready to run the simulation. So we'll speed this up a little bit, but you can see the log on the left and the output files on the right. And we're ready to process this. So we're going to click on Powered VTK on the right hand side there. And we're going to be exporting all of the parts. So we're going to call this part all. And we're going to tick open with Power View, click export. Just wait for this to export quickly. And now that's opening up in Power View. So we're going to click apply on the left. We're going to orientate this with Y+. We'll just try and bring that back. Okay. And now click play. We'll just visualize this using velocity, a bit more interesting. There we have our sloshing tank case, fully visualized. If you have any further questions, please refer to the DualSPHysics forum or send us an email at dualsphysics@gmail.com.